Hello, I'm the editor of a geographic magazine, and our latest issue is about Japan. That is my co-editor.
Wait, you can't publish that magazine. The information is not correct.
Let's take this inside. It's cold out here. Well, a lot of Japan's geology can be explained by forces.
Star Wars?
No! Like Newton's laws, gravity, friction, and inertia, things like that.
We know that Japan is at the center of 3 tectonic plates: the Eurasian Plate, Philippine Sea Plate, and Pacific Plate. How does this affect the forces at work?
All of the plate boundaries surrounding Japan are the convergent type, and a lot of the boundaries are also subduction zones, and the subduction is caused by colliding plate tectonics, and these exert a high compressional force, so one plate subducts below the other one.
More specifically, the Pacific Plate subducts below the Eurasian Plate and goes back into the mantle because the older plate is denser and subducts below the younger one.
Did you know the Pacific Plate moves only 8 centimeters per year and the Philippine Sea Plate moves 5 to 8 inches per year?
Yeah, and that's because those are objects in motion that want to stay in motion. They will continue to move unless acted on by an unbalanced force. That's Newton's first law.
Japan has many mountains, like Mount Fuji, and these are created when 2 converging plates collide. The plates have a high mass and low acceleration, so the resulting force is very large and causes mountains to form. That's Newton's second law.
Oh yeah, and the mountains keep growing because the moving plates want to stay in motion. They will stay in motion unless acted on by an unbalanced force. That's also the first law.
There are also folded mountain ranges, which are created when the Earth's crust is uplifted and folded into 2 waves by compressional forces.
Wait, back to Mount Fuji. That's an inactive volcano, right? Will it stay that way?
Yes, because an object at rest will stay at rest.
What if it becomes active?
That's because enough pressure has built up in the magma chamber and the volcano is able to erupt.
But Mount Fuji isn't the only volcano in Japan. In fact, 10% of the world's active volcanoes are in Japan.
Yep, Japan has Fuji, a stratovolcano, Hakone, a complex volcano, Azuma, a stratovolcano, Usu, a strato, Oshima, a strato, Fukuojima, a shield, and many, many more.
All of these volcanoes are created by the tectonic plates. We already know why the plates move, but when the ocean plate subducts under the continental plate because of its greater density, it causes volcanoes to form.
The stratovolcanoes are the most explosive. After all, more gases are trapped inside these volcanoes.
More gas inside causes the magma to have higher viscosity, so more pressure is put on the volcano and it erupts more violently.
Japan doesn't just have volcanoes, there are also tsunamis and typhoons. One tsunami was triggered by the eruption of Mount Unzen. The landslide that followed the volcanic explosion redistributed sediment and rock across the sea floor, which disturbed the water column. The water was at rest, and the unbalanced force of the landslide caused the water to form a tsunami.
Well, Japan is a very earthquake-prone region. This is probably because it is the meeting point of 3 plates.
I know. All the tectonic activity at the subduction zones result in friction because of the high inertia. When the land tries to overcome this friction, it shakes, and this is the earthquake.
Earthquakes are also caused by fault lines. The converging plate boundaries create friction that puts stress on the land. When the amount of stress gets too high, the land is strained or deformed. Faults are a type of strain.
I suppose we agree with everything that you 2 have said.
So you'll let us publish our magazine?
Not yet. We still need to explore a few scientific ideas.
Japan is a volcanic island formed over a hotspot. Hotspots are driven by convection, which occurs when magma moves in a circular pattern in the mantle. This movement creates energy.
No, the island arc is made because the plates are moving.
Except those plates are also being pushed by convection currents. Convection.
Convection is the main source of energy for plate tectonics.
Fun fact! The basement rocks of the Japanese islands are made of metamorphic rocks. During subduction, gravity pulls the rocks into the mantle. Then heat and pressure change the igneous rocks, and the composition changed. As the new rock rose back up to the Earth's surface, its kinetic energy slowed down. In other words, it cooled into metamorphic rock.
Colliding plate boundaries force up mountains on volcanoes because of kinetic energy of the plates cannot be destroyed. Instead, it is channeled upwards to create landforms.
Mountain building!
Hey, my favorite type of volcano is a stratovolcano. When they erupt, the lava runs down the sides of the volcano. The magma sits inside the volcano, has potential energy. During the eruption, the energy is converted to kinetic energy ball. This ball also has potential energy. When I drop it, it will have kinetic energy. Yee.
Oh my gosh, Mount Fuji is a stratovolcano and it's overdue for eruption by about 3,000 years. 300 years. Its next explosion will be big because the potential energy building inside the volcano is increasing every day.
Anyway, the lava from a volcano becomes igneous rock, you know? As the temperature of the lava decreases, it cools and hardens. Decreasing temperature equals decreasing kinetic energy.
Yeah, since the water has more kinetic energy, it's able to move more easily. That's why rivers run from Mount Fuji. When the snow at the top of the mountain is heated, there is more kinetic energy, which allows streams to run down Mount Fuji.
Well, the volcanic rocks can be split into columns called columnar joints. This happens when the lava cools very quickly. The temperature is decreasing rapidly, and so the amount of energy, the kinetic energy, is increasing so fast. And then it's kind of like putting ice into a warm drink. The ice will crack and split inside.
A conversion between potential and kinetic energy also causes the ground to shake in an earthquake.
Tension plays a role in that too. When two plates rub together, the tension between them builds up until an earthquake happens. This gradual increase of tension is also a gradual increase of potential energy.
Speaking of dinner, I like the sushi in Japan.
I like the hot springs.
But the hot spring water is always too hot.
Well, that's because of the water's proximity to the Earth's core. The warmer the water is, the more kinetic energy it has.
Japan is so exciting.
Yeah, it's so full of energy.